All right, and away we go. Let's go to number 6. Now, on these types of problems, they look more confusing than they are. They're really not that hard. All you got to do is you just got to pick a side to put the variables on, and you got to pick a side to put the numbers on, and just go with it. So let's put the variables on the left side. Let's put the numbers on the right. So I'm going to subtract 2w from both sides. Okay, and then in the same step, I'm going to add 7 to both sides, because what that does is that gets the numbers all over to the right side, and that gets the variables all over to the left side. That's the whole idea of what we're doing. Okay, that way these cancel out over here, and you're just left with 15, and then these cancel out, and you're left with negative 5w. You subtract by negative 5, and you get w is less than, because we turned that sign around because we divided both sides by a negative. It's less than negative 3. I think, didn't we have that answer already? One of these already? I think we did. Oh well, popular answer, I guess. All right, let's see if it likes our answer. Awesome. Let's keep going. Solve the compound inequality. So when you do these, you just solve them separately. Okay, pretty straightforward. Solve them separately, and then when you graph them, that's when the magic happens. And this is an and, so this is going to be an intersection. So it's going to be only the spots where they have the same stuff in common. All right, so let's start with our 2x plus 2 less than or equal to negative 2. Well, if I subtract 2 from both sides, I get 2x is less than or equal to negative 4. Divide by 2, and I get x is less than or equal to negative 2. All right, so that's one part. Okay, and then for the other one, you have 3x minus 1 is greater than or equal to negative 19. So we're going to add 1 to both sides. That gives you greater than or equal to negative 18, which is nice because that will be easier to divide 3 by. And then you get x is greater than or equal to negative 6. All right, so we're going to try this. I haven't done a compound one. I know my answer is going to be between negative 6 and negative 2, because x has to be greater than negative 6, but it has to be less than negative 2. So that's going to be all those numbers between negative 6 and negative 2. So I'm going to take this here. I'm going to go over to negative 6. I'm going to put a line. I'm going to come over here. I'm going to go to negative 2. I'm going to put another, not a line, a dot. And then notice they're filled, and they're filled because of the sign having the line under it. And then we just take our line, and we're going to tap the spot and see if I can, there we go. That's what we want. We want it there. I'm going to hit this thing to show that that's what I want. And let's hit check. And they liked it. All right, that wasn't too bad. If I can figure this out, you guys can figure it out. All right, another one. Another compound inequality. Okay, this is an or statement. So this means it's going to be any of the solutions, anything goes. All right, a union. Unions are all inclusive. All right, so subtract 1. We got 2x plus 1 is less than negative 3. We subtract 1 from both sides. You get 2x is less than negative 4. Therefore, if I divide both sides by 2, you get x is less than negative 2. All right, so I'll put this over here. Put a dot there. Put a line over here. There we go. So that's good. And then we have 2x plus 6 is greater than 8. Well, if I subtract 6 from both sides, so remember the goal is just to get the variables alone. So that means the numbers have to be with the numbers on the other side. So you get greater than 2x, divide them both by 2, and you get x is greater than 1. So we're going to have this, and we're going to move it over here, put our dot. Let's get our line. We're going to go, oh, it doesn't look like it liked our dot. Let's put our dot on again. There, x is greater than 1. Now, put our line here. We'll hit it. And then we'll see if it likes our answer. Yep, there we go. All right, so that's a union. Unions, some unions take up the entire number line, like it's all real numbers. So it's not an entirely uncommon thing. All right, graph the solution to the inequality on the number line. All right, now we are looking at absolute value problems. And absolute value problems, the big thing with these is you always have two cases. All right, you always have a positive and a negative case. So your positive case is just rewrite it how it is and solve it. So w plus 2 is greater than or equal to 5. Well, that's fine. Subtract 2, we get w is greater than or equal to 3. All right? And then your negative case is going to be taking this thing, making it negative. Because if you think about what an absolute value sign does, it takes anything that's negative and it makes it positive. So there's two different solutions with this, and we're going to figure out if it's a union or an intersection. So let's apply that negative sign to both of these. So we get negative w minus 2. It's greater than or equal to 5. We're going to add 2 to both sides. So we're going to get 7. But it's negative w. So I'm going to multiply this whole thing by negative 1. And when I do that, I'm going to flip that sign around, and it's going to change the sign of everything. Okay? So I get w is less than or equal to negative 7. So this is going to look like an or statement when we're done. So because it's less than, greater than, or equal to, we're going to use the filled circles. So we're going to go over to 3 first. I'll put that in. And then we'll go over to negative 7. Put that in. Let's see, grab our lines. We're going to go over here. Put that one in there. And then we're going to go over here and put one there. And that's how that works. I'm a regular old salty dog at these now. All right, let's try another one. Okay, so this one, again, two cases, all right? Two cases. There's always two cases, positive and a negative case. And there's always two cases of anything when you're dealing with absolute value signs. So my first one is, I don't know why I wrote that down, is 2u plus 6 is greater than 14. That's my positive case. All right? So subtract 6, get 2u greater than or equal to 8. U, I don't know, looks kind of like a y there, sorry, is 4. Okay? Because we divided both by 2. Right? Cutting some steps here, but you can see what's going on here. So u is greater than or equal to 4, so we're going to take this, we're going to bring it over to 4, and we're going to put a dot. Right now, we're going to do our negative case. So my negative case, all right, is going to be when I make this, that sum in there, make that the negative, the opposite of it, okay? So we'll get negative 2u because we're distributing this, minus 6 is greater than or equal to 14. So let's add 6, and you get negative 2u is greater than or equal to 20. And then I'm going to divide both sides by negative 2, and it's going to give me negative 10 and u, but I'm going to flip this sign around so it's less than or equal to. So I'm going to move this guy over to negative 10, and I'm going to put a dot there. And we're going to grab our signs here, and we're going to move it over. And we should be in good shape. All right, I'm going to stop the video here, and we'll finish up with 11, 12, and 13.